Hello and welcome to this video. I want to go through this week's workshop activities just to help provide a bit of an explanation of what's going on. So first of all, we can open the SPSS data file, so you can see that downloading there. I'm going to open that up, and while that's running in the background, I want you to use your textbooks for this. So if we turn to the textbook in the case in the textbook, which is on page 419, the questions that we're dealing with are this case going to be chapter 12. So the first one is question 26. Do the ratings of the psychographic statements Q14.1, Q14.2 and so on differ for males and females? We need to formulate the null hypothesis and the alternate hypothesis and then conduct the appropriate test. So I think SPSS is starting up here. So I've already started writing this down in here while that loads. The null hypothesis is going to be do the ratings for the psychographic statement differ between males and females? So we're basically saying for the males and females it's going to be the same. So the alternate hypothesis is going to be different. Now, if you think that's a leap of logic going from this question here, saying do the ratings of psychographic scales differ, then you really need to be looking at your textbook, because it gives a really good example there of how that logic flows. So I'm just trying to find it right now. SPSS is open in the background. So in here for this week, under data analysis, hypothesis testing, related differences, correlation and regression. So you're going to think about what are we asking. If the psychographic statements, if they differ, that's a test of, now everyone that's hopefully listened to the lectures will be thinking, oh, that's a test of difference. And what do we use for test of differences? We've got hypothesis testing relating to differences. And that talks about the t-tests. We can have a one sample t-test, a two independent samples t-tests, or the paired samples t-tests. So if we're talking about differ here, we know we're talking about difference, so it's a test of difference. So we should really be thinking, well, it's obviously going to be a t-test. What type of t-test? Is this going to be a single sampled t-test? Are we drawing one sample and comparing it to what we might have expected to find, as we did in the YouTube video? Or are we actually going to be comparing one sample with another sample? And you'd think that's pretty obvious. Well, we're going to be comparing one sample with another sample, and that's males and females, right? So we're going to be doing a two samples t-test. Now, is it going to be independent samples or paired samples? Paired samples is when you use the same cases or the same respondents in one test and another, or you're drawing them from exactly the same population, from one and again. Is this population the same? No, we're doing one population is males and the other one is females. So is this test going to be, so if these two are independent of each other, independent samples, it kind of makes sense that we're going to do a test of difference. So we're going to do a t-test. We're doing two samples, and it's going to be independent samples. So we're doing the two independent samples t-test. Right, now we've got SPSS up and running in here. So what we want to do then is we'll go analyze. We're going to go, where's it gone? Compared means. And we're going to go independent samples t-test. All right, I'm just going to grab my box because I'm working on two screens, everything's going everywhere. Right, now it's quite hard to see what all these things are, so hopefully by now you know that you can right click and go display variable names. Right, so what we want to do here is, I'm going back to my question so I can find out what we're actually doing. So do the psychographic statements Q14 and so on differ for males and females? So the test variables are going to be Q14 to Q1. Buzzer, put them there, and the grouping variable is going to be gender, which is S2, right? So if I go variable names, are you, so I'll actually show you there, but that's the answers there are male and female, so I'm going to put that there. Right, Now this is the tricky bit. This is where people get stuck, because here I have got S2, 2 question marks, define groups. Oops, I'm going to, it's on my other screen, pull it back here. I'm going to have group 1 equals 1, group 2 equals 2. Simple as that. Continue. If we're doing more complex analysis, then we'll be using this more, but for this point it's actually pretty easy. So we'll go like that. And then we can look at our options. If we want to exclude cases, analysis by analysis, that's case-wise, list-wise. That's case-wise deletion, and that's list-wise deletion, right? So it defaults to case-wise. We've talked about in the lectures before. So just leave it to the default, which is pretty easy. The bootstrap we don't use. That's if we're trying to do a lot more complex analysis. So we're just going to go OK. And that is going to, right, so at the top here, it has our code, which tells us what's going on, blah, blah, blah. And in here, it gives us our group statistics. Now, we've got two samples. We've got male and female. So the first one is, which is the psychographic question, is Q14.1. You can actually look in your textbook here. If you go to, at the back, on page 422, at Q14, find it here, sorry. Q14.1. Alright, so this question here, Q14.1, try to stay current on the latest health and nutrition information. And they're giving a response on a 5-point Likert scale. So we know for Q14.1, which is the answer to this question here, I try to stay current on the latest health and nutrition information. 633 males answered that, and they gave an average score out of 5, from 1 to 5, of 3.2, with a standard deviation of 1.22, which standard deviation means how spread out the data is. So did everyone choose 3.2? Well, that doesn't really make sense, but because you can't choose 3, but did nearly everyone choose 3 and a couple of people choose 4 to average it out to 3.2? Was it all 3s and 4s, or is it spread? Is there like 1s in there? So how far, how spread out is the data? And the standard error of the mean is how confident we can be in that result there. So we know also that there were 808 females answering. So there's more females answering, and their average response to that question was 3.47. So we already know that the females score higher than the males. So the question was, remember, do the ratings for the psychographic statement, so this is a psychographic statement here, differ for males and females? We can see that they differ. Males are 3.2 and females are 3.47. We know they differ. Now the question, the reason why we're going, and anyone can sort of work out that using simple descriptive statistics, but what we are really testing for are they significantly different, right? And that's why we run these tests. So if we go back down here now, we can see where we have the same variable. So I try to stay current, blah, blah, blah. We have our F statistic of 2.97, which, 2.979, which doesn't mean a lot to us, but that's converted to our significance. For we're testing for Levene's test of variances. Is it significant? No, it's not significant, which basically means we cannot assume, we can't reject the null hypothesis saying that they are equal. So I can't remember what the null hypothesis is there, but basically we can't assume that they're equal, so we have to go equal variance is not assumed. Now when we look at this, it doesn't really make much difference anyway, because this is basically telling us, so this significance here, this bit here is telling us whether we're reading the equal line, equal variances, or equal variances not assumed, right? So are we assuming variances or not? So this is telling us which line, top one or the bottom one. But when you go through here, the lines are the same anyway. The significance, they're both less than 0.01. So most of the time, people just jump straight to these and go, they're all 0, except for these ones. And the top one and the bottom one are much the same value anyway. So I'm not too hard on you if you get this bit wrong or you skip this step, because for what we're doing at the moment, it doesn't make a big difference. But if you want to get it right, you'd go, the test for equality of variances fails to reject the null hypothesis, therefore we can't assume that variances are equal, therefore we're going to assume that they're not equal, therefore we're going to go with significance of 1.1, which is greater than our half alpha, which means that we fail to reject the null hypothesis, which means we have to say that the difference between males and females for this one here, I consider the amount of fat in my food in the kids for my kids eat at restaurants, there isn't any significant difference between male and females. Now I'm going to go back up the top here and let's have a look what that says. So I consider the amount of fat. You can actually see there is a difference between, make sure I got the right one here. The one that fails to be significant is I consider the amount of fat in foods my kids eat at restaurant. I consider the amount of fat, yeah, so this one here. So although they are different, 3.1, 1 and 3.25, the difference isn't as big as normal as some of the other ones, and the difference isn't significant, all right? So for here, we'd write it up then and go, well, what I want to do is actually, I'm going to show you, so I'm going to copy this one, right click, computer's going slow. While I'm recording, my laptop has a bit of a harder time doing it, so we're going to copy that. Now, I've already started writing this up in here, so I'm going to paste that in there. I might actually place that as a picture, just because I don't want to spend too much time mucking around with formatting. So we go back to the output file. I'm going to put this in there as well. Control C, it's quicker in this case. Control V. And again, I'm going to paste this as an image just for simplicity's sake. Ooh, shivers. Now I'm going to have to shrink it. Hang on. How am I going to shrink it? Right, there we go. Home. If we go to view 100%, right, so here, I have to zoom in anyway, so here we can, this is the column that we're looking at. So if I go insert, I go shapes, in here, I can just go like that, and I'll change that to something like that. And there we go. So this is my SPSS outputs. If I was writing up a report, this is what I'd include in there. Normally you'd highlight the ones or there, just so that it makes it easier to see. If you do this red thing around it, that works as well, right? I'm not too worried about the formatting. I just want you to be able to show me what the important thing is. Make sure you don't get the significance for the test of equality, which is easy to do, because you'd go, oh, none of them are significant, but none of them are significant in assuming that the population variance is the same, but the actual real test, where the test for equality of means, is significant, or except for this one. So now I'd write something up there and go, I'll let you write this up, but basically you're going to be answering this question here. So you'd go, all of the PS psychographic statements are different for males, not means, males and females, except, which was it? I can't even remember what it is. It is, I consider the amount of fat, blah, blah, blah. So I might just, for simplicity's sake, except, and then you'd write that. I don't want to tell you exactly what to write in there, because part of the skill and part of you demonstrating you know what you're doing is being able to do the analysis and then explain what that means. If you can do the analysis but you can't explain what it means, then you don't fully understand it, all right? So that was exercise 1. Now for exercise 2, it goes, do the respondents agree more So there's a big hint there. I've been making an effort to look for fast food choices that have been better nutritional than I've chosen for the past. Then they do with, I consider the amount of fat in my blah, blah, blah. Formulate the null hypothesis. So, what I want to do there is think about if I'm doing is this going to be a one-tailed test or a two-tailed test? And I'm just going to pause it right here. Okay, so we want to formulate the hypothesis. So the null hypothesis, HO, is equal to, what we're looking at is the response degree more. So we know we're going to have a greater than symbol in there. But what we really, so I'll write this out and then I'll flip it around. So question 14.6, where is it? Question 14.6 is greater than, what's he saying? The respondents of 14.6 than they do with Q14.5. So Q14.5. Now, I've written up a little bit wrong because that's the alternate hypothesis that we're trying to prove, right? So the null hypothesis is the opposite of that. So we go H0, do it again, equals, now I'm going to just, for simplicity sake, I'll type it out. So Q14-6 is less than or equal to. Now this is what I needed to find. So we go symbol. So under here, if you go, we're often at home. If we go insert, we go symbol less than or equal to Q14-5. So this is what we're trying to prove, that it's less than or equal to, and then if we can reject that and we go, that's going to be wrong. Hang on, I'm just going to make this a little bit more dramatic. If I can cross that out and prove that statement is false, then I can actually accept that statement as true. All right, that's what we're going for. So now we've got to think about what are we doing here. So we're doing a test of, what sort of test are we doing? It's not immediately, because this one here is actually quite simple. It says, do they differ? So we know we're doing a t-test of differences, right? So in here, it doesn't say the word different. So it's a little bit tricky, but it goes, do respondents agree more with something than they with blah, 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 all right? So if it's more than something or less than something, with agreement, kind of is difference, right? But it's not just about if it's just different at all, but is it different a certain way? Is that difference greater? Is it more than something? So it doesn't say the word differ, like different would be, the word different would be a clue that we're using to test a difference, but we are testing for difference because if it's different, more than, all right? So now the test that I want to do is a t-test, but what type of t-test? So now, in the previous one, we had a sample of, I can't even remember, it was males and a sample of females. Right, so we had two independent samples, males and females. In here, it's got do the respondents. So what I'm focused on is the respondents, blah, 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 blah. So I'm not testing between males and females. I'm not testing between, like Tasmania and Western Australia. I'm testing the same people, right? So this is going to be a paired samples test. So if I go into here and go case here, I go data. No, sorry, not data. Analyze. I was looking for data analyze, but it's analyze, and then we go compare means, which is where our t-tests are. And we can do paired samples t-test. All right. So now, what was our pair again? I'll keep forgetting these questions. So in our book, 27, Q14 and Q16. So let's check this out. Numerical names, Q14, no, Q14.6 and Q14.5. All right, so this one and this one. Right, now, some students ask, which way it goes. I think it does print out different results which way it goes, but it's not too bad because it's going to be more than or less than anyway. So we exclude the case analysis one else, so we keep that the same. We don't want to do any bootstrapping, so we can just click okay, and let's see what it comes up with. So here's our paired samples t-test. So for the first, so this is a hint, right? So this is a, no, we've got the right one, that we've got the paired samples, because the same number of people responded for pair 1 for this variable as this variable. So it's kind of cool. Remember the previous test, I'm just going to jump up to the previous test, the previous t-test up here. They had 633 males and 808 females. So there's actually difference, right? So these aren't the same things. Two different samples. Whereas we're going to go back to the t-test we just did now, it's got the same number. So it's not guaranteed, but it's sort of an indication you're on the right track, right? Now I look at this and go, for this variable, considering the amount of fat and be making an effort, it is different, right? So we said, what was the thing? Is one greater than the other. I'm just trying to remember what's going on here. So I've been making an effort is actually greater than, so do they agree more with? Yes, they agree more with this one than they do with considering the amount of fat, right? So just by simple statistics, descriptive statistics, I can already tell that the answer to this is yes, kind of, yes. This variable is greater than this one, but is it statistically significant? And that's why we run these tests. So, you know, anyone out of high school can just do, add up the means, work out the averages and say, yes, one is greater than the other. But, you know, we're a bit beyond that. We're actually testing for a significant difference between the two of them, right? So in here, it tells us how many, blah, blah, blah. Significance is, correlations, significant there, and it is here, which is what we're looking for, the significance in the paired samples t-test. So don't get confused with the paired samples correlations. I'm not sure why that came in there. It must be from something I clicked in earlier. Paired samples t-test, we're doing where's our t statistic? Here, negative 5.116. What's the p-value for that? T-value for that t statistic, what's the p-value of that? And it's less than 0.01. So yes, what we can say is that there is a significant difference between them, and that significant difference is greater than. So what I can say now is, oh, hang on, I gotta paste the results in there first, right? So I'm gonna go Control copy that one, paste that as a picture. Alright, and I want the independent samples. Shit, did I do the wrong one? T-test. Alright, so paired samples, and I want this one. We don't have to worry about Cohen's D and Hedges correction yet. If you want to explain what that is in your work, go ahead, do it. I love to read it, but I'm trying to keep this as simple as possible at the moment to get you through. Right, paste that. Alright, and we'll make that smaller to there. Alright, so now I've got to write that up so I can say, why have I got, oh, this was the wrong one. Sorry, I'm deleting that, because what I should have done, remember I asked if I grabbed the wrong one, and I didn't. I grabbed that one. So this is one of the reasons why I shut down the output files all the time, because, ooh, not that one. Bang. Paste that as a picture. Right, now I'm going to write something up saying yada yada yada. Yes, the respondents agree with normally you'd, with making an effort for nutritional, is that spelled right? Nutritional food, and then I'm just going to put in there. So you can. I want you to write this up in your own way. Q 16, Q14, 6, then what was the other one? Then considering the fat in food. Can't type food. Right, I need the word significant in there. Yes, respondents. I'm not sure how to work that into the sentence now. Significantly agree. That's not very smooth. Significant. I'm just going to leave it like that. I'm not going to make it look too pretty. If you can work the word significant into the way you type that out, great. If you just copy what I've got, this is actually a good way of doing it. If you copy what I've got, it's not the best way you can do it. So I want you to think about it, read the text. I'm trying to do this on the fly as well. So the last one that we want to do is this one here. Now this exercise 3 is a small question, but it involves a fair bit of work. So this one is tricky. I reckon this is the trickiest one to know what to do. Because it says, can the restaurant ratings be explained? Now, that doesn't really tell us what test to use overtly, right? This one here, I think is quite simple. I mean, this one's really simple. It says, do they differ? So it's a test of difference, right? This one here is, do they agree more with? So you're like, well, more than what we need to work out. If it's more than, we need to do a test of difference, right? So it's a step away. This one here, question exercise 3, it says, can each of the restaurant ratings be explained? Now, what test do we use to be explained? And it's really hard to explain things using statistics. We need to use, one way I think about this is, it's the hardest thing to do, so we need our most powerful analysis, and that is regression. So regression actually explains what's going on in the data. It says, when this happens to the variable X, then we can explain what happens to variable Y, right? So this one, I'm going to tell you right now, is a regression. And I know that because I'm the lecturer and I've read ahead and I've prepared all this stuff. If you think that's a little bit tricky to get from explanatory question to regression analysis, yes, I can see your point, and makes sense. It's just more incentive then for you to read and understand what regression analysis actually do, right? So I want to formulate the hypothesis. I'm going to quickly pause it here again. I noticed in the workshop today that they didn't actually formulate a hypothesis in the textbook, so you do not have to formulate the hypothesis here. Alright, so we're going to work out what the null hypothesis is. So the null hypothesis for regression is that there is, so the null, the H0 hypothesis is there is no, you could do, in the textbook, it's got in there for regression, it's got an associative relationship, relationship. In here, I'm just going to do, so associative, but this one's explained. So you could do explanatory relationship. Associative relationship can also be used correlation as well. So whereas we do regression, which is more powerful, it actually formulates the multiple regression model, which is also, it's that y equals a plus b plus multiplied by x1 plus b1, and so on and so forth, expands it out. So the null hypothesis, there's no explaining relationship for between restaurant rating and psychographic statements. Alright, cool. So then of course H1 then is going to be exactly the same, but instead of saying no, you just go there is an explanatory blah, blah, blah. Alright, so once we've got this far, we can now go in here, Wendy's case file, we go analyze, we go regression analysis, here it is, linear regression in there. Right now, variable name. So we've got multiple independent variables here. It's easy to mix up the dependent and the independent variables, but in here we've got multiple independent variables which were, now I can look at my textbook here. I'm having a hard time trying to remember everything I'm supposed to be adding in here. Alright, so is Q9 oh hang on, no, Q14 sorry, Q14 we got all these ones here are the independent variables, and the dependent variable is our Q91. So this is Q91 here. So these, we want to do these four, right? And you notice we can only add one at a time. So we're going to have to run each one of these separately. So the first one, now Q9, if you look in the survey, Q9, question 9 is, where's it gone? Q9. It's the restaurants, right? Which type of restaurant it is. So I'd like you to rate the restaurants. So on page 4222 in here, you can see it in there. I'd like you to rate the restaurants you yourself eaten in the past 3 months using a 10-point scale, where 10 means you think it's perfect and 1 think it's terrible. They can count everything, blah, blah, blah. And they do that for each restaurant. And at the end of the textbook, right at the end there, they have a legend that goes over 1, and question 1, so question 14, for question 9, response 1 is called Arby's, so we'll do that one first. So this is the restaurant, and these are the psychographic statements. Now for the statistics, you shouldn't have to change too much in here. We keep that, whatever's checked. We do our model fit. We don't have to worry about the change in square R, blah, blah, blah. We don't have to worry about this stuff as well. We'll do continue. You can plot it out if you want, but for this one I want to keep it simple. So I'm going to click OK. Now this box is here. I explained it in the face-to-face workshop. Normally our labels, our variable labels, aren't the full question. We try and summarise them a little bit. And here it gives us the R squared. Now this is a very low R squared for this one here. And if you look at the ANOVA, analysis of variance here, we've got our sum of squares, square root of freedom, our mean square, and our F statistic here. But our significance is not there, right? So this relationship is quite small, but it's insignificant. So then we'd write there, let's just copy those, we'll paste those into here, and then we go, oh shivers, I don't want all that, that looks a bit, maybe I'm just going to delete that to make it look a bit more beautiful. You can play around with the editing if you want. Delete rows. Alright, cool. So I'm going to go here now. Oh, this is terrible. This is what happens when you got really big labels. It makes things harder. So then you can go the R square is 0.005, and then you could write the adjusted R squared, the significance, and you'd write up explaining that it's insignificant. Right, now I'm going to do the next one here. I'm just going to shut that output file down because this is getting big now. I'm going to open this one up there, run it again. So we do analyze, and we do not multiple response, we want regression. Oops. Let's do linear regression. Oh, it's correlate. Where's regression gone? It's a bit slow in my computer. Struggling with the... So we do linear regression, and then instead of doing Q9, we're going to do Q7 now. Bang that in there. Click OK. Now the output shows what's been in there. We haven't removed any variables, which is cool. Our R squared is still quite low, but our ANOVA shows significance in there, right? Now in here, so because now it's significant, so we'd actually report it and say yes, for our null hypothesis, we can reject this one. So this is going to be the first test. So that was for a restaurant. What was it? Q9-1, which is Arby's, I think it is, A-R-B-Y'-S. Now the next one is going to be for Q9-7, which is Burger King. So in here you go, Arby's is, for Arby's we can actually say there is no. So when you write that up, reject the null hypothesis for Arby's, and you can accept this. No, you cannot reject it. Sorry, remember we didn't get it significant, so we can't reject it. So we go, you write up that there is no explanatory relationship. Whereas Burger King, when we look at our things here, our output, we have our. We can copy this into here, and we can say it's significant. Our F statistic shows that it's significant, and our R squared is 0.057. So, and that's actually quite low. So you go, yes, there is a significant blah 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 associative relationship or explanatory relationship between the rating for Burger King and these psychographic statements, and then you can also for the output here you can look at the coefficients. I've explained what the beta is in here. That's used for working out our, hang on, in our textbook it's got it written there, the formula basically for our regression model in our textbook there. So where that says y equals beta or a plus b blah blah blah, we use these figures to work that out there and the significance of that as well. Alright, that's it. That's all I've got time for now. I look forward to seeing you next time.